Hi and welcome to wrist training. In between the exercises I'm going to read something about parenchyma and try to learn it. And participating in the exercises is at your own risk, and parenchyma has to do with internal anatomy and how cells biologically work at the intern. So I'm going to talk most of the time about, in a biological way, about how the body works, cell works, and also tumors and organs. Let's start with the first exercise. We're having both arms next to us and the hands formed to fists. And now we bring these fists down and again up. And if you feel at any moment during any of these exercises pain at the wrists, then stop immediately. So we're going down and we're going down as fast as we can bring them down with a little bit of effort. And as soon as we have reached the point which you could reach with a little bit of effort, we're turning around and are going into the other direction. And we're never doing this until exhaustion, so this is now the last time. And now to parenchyma. Parenchyma is a part of organs. It is a part of organs. Organs are the human body. Lung, heart, liver, kidney, and so on. There are two types of something which make an organ or a tumor: stroma and parenchyma. So, organs or tumors consist out of two different things, types. Stroma is the structural part, parenchyma is the functional part. No further explanation, but stroma seems to give just the structure of the organ, whereas parenchyma does the function. However, that has to be imagined. Now to the next exercise. It is, that just was the spotlight, the flashlight. We're having again both hands and fists next to us, but instead of bringing them up and down, we are bringing all these fists to the inside and to the outside. And same rules. If you have pain, stop immediately. And we're going only as far as we can go with a little bit of effort, and as soon as we've reached the point which we could reach with a little bit of effort, turning around and then going into the other direction. And as the third and final rule just mentioned, whenever you're doing this until exhaustion, so that makes this the last one. It was the flashlight. So, parenchyma. Organs and tumors consists out of two parts, that tissue or whatever these organs or tumors consist of, are composed of. Stroma and parenchyma. And stroma is the structural part and parenchyma the functional. The structural stroma part of organs or tumors is the connective tissue. So it is just a tissue which, it's the structure, it builds it. Damage to the functional tissue part parenchyma in the brain leads to loss of cognitive abilities up to death. So the parenchyma part should not get damaged in the brain. Otherwise that leads to cognitive problems or can be severe, but it leads to death. It was loss of cognitive abilities. So the parenchyma part, the functional part. Stroma, structural, parenchyma, functional. The parenchyma part, the functional part of the brain should not get damaged, otherwise it leads to loss of cognitive abilities and death, possibly. The next exercise, it is the magician. So now we have the arms with flat hands next to us, and now we bring these flat hands to the inside and to the outside. And to the outside, and again to the inside, and again. We're going only as far as we can go with a little bit of effort. And when we're turning slowly around and are going into the upper direction. And for our last time. Stroma is the structural part of organs or humans and parenchyma the functional part. And in the brain, the parenchyma part, the functional part should not get damaged. I guess the stroma part should also not get damaged. Bleeding in the functional parenchyma part of the brain is called Intraperenchymal Hemorrhage. Intraperenchymal Hemorrhage. So hemorrhage is something to do with blood, hemo is blood, hemorrhage, and intraparenchymal, maybe it's a type error, intraparenchymal hemorrhage. So intraparenchymal hemorrhage, if it bleeds into the parenchyma part of the brain, then it is intraparenchymal hemorrhage. In the lungs, the functional parenchyma part is involved with the gas exchange. The alveoli are part of the functional parenchyma part of the lungs, in which the carbon dioxide against oxygen exchange happens. So the alveoli in the lungs, which are small parts where this gas exchange happens from taking the carbon dioxide out of the blood and putting oxygen back into the blood. So carbon dioxide comes out of the blood, and then it's breathed out, and oxygen comes into the blood. So in the lungs there are the alveolis, and in the alveolis the lungs come with carbon dioxide in them, and they are split. I just read it. I don't know much about it. And in these alveolis there's a small membrane separating the blood which has carbon dioxide in it, and on the outside of the membrane there is oxygen. And this is all so small that a chemical reaction can happen, and the carbon dioxide can exchange with the oxygen or something like that. So in these alveolis they are very, very small, and they have an exchange of carbon dioxide from the blood through this very, very thin membrane that the oxygen can happen, and carbon dioxide comes out and is breathed out, and oxygen comes into the lungs and is transported to our body parts where oxygen is needed, and they are then somehow changed to carbon dioxide and something like that. The next exercise, it is the pancake clapper. Both hands with flat hands next to us, and we bring these flat hands up to the sky and down back to the ground. And we're doing this again slowly and concentrated, only if it is painless, going always as far as we can go with a little bit of effort. And as soon as we reach the point which you could reach with a little bit of effort, turning around and going into the other direction. And final rule, not until exhaustion. So this is the last time. Sky and back to the ground. So the parenchyma part, the functional part of the brain, should not get damaged, otherwise it gives loss of cognitive abilities and can lead up to death. Bleeding into the parenchyma, the functional part of the brain, is called intraparenchymal hemorrhage, and the alveolis in the lungs, the part where the gas exchange carbon dioxide out of the blood and oxygen into the blood happens often in the lungs. The alveoli are part of the parenchyma part, functional part of the lungs. So the lungs have also a parenchyma part, and this parenchyma part is, for example, the alveoli. But the lungs have, I guess, also a stroma part. So stroma, structural parenchyma, function. In the liver, the functional parenchyma tissue is the so-called hepatocyte. The functional parenchyma tissue of the liver hepatocyte is involved in protein synthesis, protein storage, and transformation of carbohydrates. So, the livers have a parenchyma functional tissue part, and that is hepatocyte. And it is involved in protein storage, protein synthesis, and transformation of carbohydrates. The next exercise, it is the T-Rex in the T-Rex in the morning. So both hands with flat hands out, and we bring these flat hands down and again up. So also the livers have a stroma part, even though it's not mentioned here. But I guess they have a stroma part. But they have, yes, I know they have a stroma part. The livers have a parenchyma part, a functional part. The parenchyma functional part makes 80% of the volume of the livers, even though it is not completely as much of the cells themselves. The stroma part makes 20% of the volumes, and I think it was 35% of, was it the last time, of cells overall. So the liver has also a stroma part and a functional part, a stroma and a parenchyma part, and the functional part, the parenchyma part, for example, it is called hepatocyte, does protein synthesis, protein storage and transformation of carbohydrates, but it does also detoxification, modification, and excretion of exogenous and endogenous substances, initiation of formation and secretion of bile. Bile is that is used for digestion of lipids, and lipids, if I have glanced at it correctly, that are just fats. So lipids are fats or something. And these bile, which is another name for gel, helps to digest lipids, which are fats. And now to the tumors. Also, tumors have two distinct parts, stroma and parenchyma. The functional parenchyma part consists of neoplastic cells. So tumors have a functional part, solid tumors or some, I don't know, solid tumors, and that consists out of neoplastic cells. The neoplastic cells of a parenchyma part are inducing the structural stroma part. They are inducing the structural stroma part. So what do we have to imagine under the neoplastic cells are inducing the structural part is a difficult job. So we just take what is written. We have the neoplastic cells, the parenchyma part, are inducing the structural part, the stroma part of the solid tumors, which is needed for nutritional support and waste removal. I guess it is meant the structural part, which is induced by the neoplastic part, which is the parenchyma part. So the structural part does nutritional support and waste removal, however that looks in the tumor. Okay, clusters of a functional parenchyma part of tumors are separated by something called basal famina. Clusters of parenchyma part of solid tumors, I guess, without clusters, and they are separated from whatever, maybe from other clusters, maybe from the structural part. They are separated, sometimes incomplete, through a basal lamina, through something called basal lamina. And with that we are through everything written there. And we have made our way to the next exercise. It is the T-Rex. He's now in the gym. It was just in the morning the T-Rex, and now the T-Rex is in the gym. So we have a tennis ball, we're holding it like this. If you don't have a tennis ball, just do it with the fist. And now we are pressing with moderate force onto the tennis ball. And we're releasing again. And we are pressing again. And we are releasing. And we are pressing again. And now we're switching and doing the same on the other side. And we're releasing. And we are pressing again. Now for the other side. We are pressing. And release. And I don't have time for the last two exercises, so we just switch to the relaxation exercise. So this is the lower part of the arm. So we're making a straight arm, and now we're making a little bend in the arm. And this is the brachioradialis muscle. And we're going with these three fingers next to it. Here's the brachioradialis, and we're going a bit inside. Now we're moving with moderate pressure downwards over the middle part of the lower arm. We're having a little bend in the elbow, with three fingers here, and we're going with moderate pressure downwards. At this place lies the extensor digitorum muscle, which extends the hand up. It extends the digit, it extends the fingers. The extensor digitorum muscle. And the same on the other side. So straight arm, make a little bend with these three fingers next to the brachioradialis over the extensor digitorum muscle, which is extending the digits downwards with moderate pressure. And we are done now with wrist training. Parenchyma. So there's the stroma part of organs and tumors, which is just giving the structure, and there's the parenchyma part doing the functional job. For example, the Alveoli in the lungs, doing the gas exchange from carbon dioxide out of the blood and oxygen into the blood. Or in the brain, there's a functional part, and if that gets damaged by bleeding into it, it's called Intraperenchymal Hemorrhage. And if that gets damaged, that leads to cognitive disabilities, so cognitive problems, and can lead up to death. And the liver has also a parenchyma part that is called hepatocyte, and that does protein storage, protein synthesis, and transformation of carbohydrates and stuff like that. And organs, tumors have, also solid tumors have also a stroma part and a parenchyma part. And the parenchyma part is also made of neoplastic cells, and these neoplastic cells inducing the structural part. And these neoplastic cells, clusters of functional parenchyma part tumors. So these clusters of the function, I don't know how to tell it. I thank you very much, and until the next time.